morning friends. Already we discussed about the PN junction, how the PN junction is formed. Now in our daily uses or in the circuit diagram, the PN junction diode is connected in which manner? Here the two different manner or the two different way we can connect the PN junction diode in our regular circuits. Right? Here the forward bias and reverse bias. Today we are going to discuss about the forward bias connection of PN junction diode, and also we are going to discuss about what is the characteristic of PN junction diode connected in forward bias. Right? Therefore, what's happened in forward bias connection? What is the mechanism when we connected the PN junction diode in forward bias? Okay. For that purpose, the question is that explain the forward bias connection of PN junction. Right. First, we discuss about the different type of connection of PN junction. PN junction diode is connected in two different manner. First is the forward bias, and second is in reverse bias as per our requirement. Okay. Now, PN junction diode is connected in two different manner. First is forward bias, second is reverse bias. Now, what is the forward bias connection? Now, when the positive terminal of a battery, external battery, is connected with P side of a junction and negative terminal of a battery is connected to it, N side of a junction, such connection is known as the forward bias. Already we know that in a PN junction diode, the symbol is this. There is the P-type semiconductor, there is the N-type semiconductor of PN junction. When the positive terminal of external battery is connected with the P section and negative terminal of a battery is connected with N section of a PN junction, such connection is known as the forward bias. That is shown in the figure. There is the PN junction. Okay. P side is connected with the positive terminal of external battery and negative side, that means the N side or the N-type semiconductor is connected with negative terminal of an external battery. Such connection is known as forward bias. Right? Therefore, forward bias connection of PN junction is shown in figure A. So this part shows the forward PN junction is in forward bias. Clear this? Okay. Now in forward bias connection, what's happened? What about the depletion barrier or the width and height of the depletion barrier? For that purpose, what's happened? Look. Now in forward bias, the electric field due to external battery and electric field of depletion layer are in opposite direction. We also discussed about that in PN junction diode. When the PN junction is formed, at that time the electric field near the junction is established. The direction of this electric field is from N to P. Its potential is V0. Therefore, the direction of electric potential in depletion layer is in the direction from N to P. Now we connect this PN junction with an external battery in forward bias. Therefore, the applied voltage is in this direction, from positive to negative. Clear? That means in forward bias, the electric field existing in depletion layer and electric field due to applied external battery are in opposite direction. Thus, the potential of the external battery V and potential V0 existing in depletion region oppose each other. Both potential are in opposite direction. As a result, the width of a depletion layer or the potential barrier and height of the potential barrier also reduces. So as a result, the width and height of the potential barrier reduces. How the width and height of the potential barrier reduces? So when the PN junction is formed in N-type region, there are the majority charge carriers are electron, while the minority charge carriers are hole. Hole are the minority charge carrier in section of the N region. While here in P section of the P region, majority charge carriers are hole, while the electron are minority charge carrier. In P region, majority charge carrier are hole, minority charge carrier are electron. During the formation of the PN junction, the electron from N region are diffused in P region. And when this PN junction is connected in forward bias with the external battery, during the diffusion of electron from N to P, now the P side of a junction is connected with the positive terminal of a battery. Therefore, what are the electrons diffused from N to P region are taken by the positive terminal. Therefore, instead of diffuse in whole of a P region, this electron directly pass through the side. Therefore, the negative ions and positive ions deposited near the junction is less. What are the electrons diffused from N to P are taken by the positive terminal of the external battery, so this electron directly pass through the external circuit and forms the electric current. The similar way, the hole diffused from P region to N region during the PN junction. So what are the holes? Are diffused from P to N. Instead of diffuse with the electron in N region, here this end of the external battery is connected with the negative terminal. Therefore, these holes are attacked by this external negative terminal. So these holes are passing in this direction. Therefore, in forward bias of PN junction, the width and height of the potential barrier reduce. So number of positive ions deposited near the junction in N region and numbers of the negative ions, ionized negative ions deposited near the junction in P region are decreases. Therefore, the width and height of the potential barrier reduces. There is the mechanism in forward bias. Clear this saying? Okay. Again, when the PN junction is connected in forward bias, during the diffusion of negative ions from N region, negative ions, that means the electron, from N region to P region. So P region is connected with the positive terminal of an external battery. So this electron are taken by the positive terminal of a battery, so directly passes to the external circuit. The same manner, the hole are diffused from P to N region are taken by the negative terminal of the external battery, so hole are flowing in this direction while the electrons are flowing in the opposite direction of the hole. Thus, the number of positive ions deposited or the ionized positive charge deposited near the junction in N region and ionized negative charge deposited near the junction in P region decreases. So as a result, the width of a potential barrier reduced and also the height is reduced. Height is reduced, that means the intensity of the potential in depletion region is decreased due to the less ionized charges are deposited. Initially, there is shown by the blue line without any connection. There is the width of a potential barrier of the depletion layer, and there is the height of the potential barrier. This. As connected in forward bias, so width of the depletion layer is shown by the dot line, and height of the depletion barrier is shown by the dot line of pink color. So the height and width of potential barrier reduced in forward bias. Clear this thing? Okay. So there is only for understanding what mechanism take place. So it is very easy to write the answer of this question. Now, the work done by the electron will be less to move from N to P. So work done by the electron is less to move from N to the P, and more electron can cross the junction. More electron cross the junction easily. Similarly, the hole can easily cross the junction from P to N. It means the work done by the electron to move from N to the P, but to cross the junction is very less. So easily can cross the junction. Similarly, the hole from P to N easily cross the junction. Thus, in forward bias connection, the total current is the sum of diffusion current and hole diffusion current and electron current. The hole are moving in this direction, electron are in opposite direction. Therefore, the total current in forward bias connection is the sum of hole diffusion current and electron current. Right? Okay. The direction of current in the junction is from P to N. The current is flowing in the junction is in this direction I. From P to N during the forward bias. There is the conventional current that is shown in the direction of motion of positive charge. That means in the direction of motion of hole. The magnitude of current is in order of milliampere. The magnitude of the current is in order of milliampere. So this is the forward bias. The same wording for the reverse bias. First we again repeat the forward bias. The PN-junction diode is connected in two different manners. First is the forward bias, second is reverse bias. Here we discuss about only forward bias. Therefore, I take first the definition of the forward bias. When the positive terminal of a battery is connected with P side of the junction and negative terminal of a battery is connected with N side of a junction, such connection is known as forward bias. Hear this? Okay. So the forward bias connection of the PN junction diode is shown in the figure. Now, in forward bias, the electric field due to the applied external battery and electric field established or the existing in depletion region are in opposite direction. Because in depletion region, the electric field is in the direction of N to P, while the applied external field is from P to N. Both are in opposite direction. Thus, the potential of the applied external battery and potential V0 existing in depletion region oppose each other. As a result, the width and height of the depletion potential barrier reduces. How reduce? Already we discussed. How they reduce? It is need not to write down in the answer of this question, but keep in mind that why or how the width and height of the potential barrier reduce. That is shown in figure B. So one in figure B. So how the electric current formed in this connection? Now, the work done by the electron to move from A region to the P region is less, and more electron can cross the junction easily. The work done by the electron to move from P to A region is less. Therefore, the number of more electrons can cross the junction. Similarly, the hole can easily cross the junction from P to N region. Thus, in forward bias, the total current is the sum of hole diffusion current and also the electron current. The direction of current in the junction is from P to N region. P to N region. And the magnitude of current is in order of milliampere. Is in order of milliampere. Clear this? Okay. So there is the forward bias. Just we discussed about the forward bias of PN junction, right? There is also important question of 2 marks. Now, the next question is that what is the forward bias characteristic? Or explain the forward bias characteristic of PN junction diode. Before starting the answer of this question, what is the static characteristic of PN junction diode? Static characteristic, that means as we change in applied voltage, whatever the change take place in current. That means the voltage current relation is the static characteristic. Right? For this PN junction diode in forward bias, as we change the input voltage or the applied voltage, whatever the change take place in current in the circuit. So that is known as the static characteristic of forward bias. Okay. Now, 2 marks question is also asked like that way. What is static characteristic of PN junction diode? And explain the forward bias characteristic. Again, we repeat the question. What is static characteristic of PN junction diode? And explain forward bias characteristic. Okay. Now, the curve I versus V. That means the graph of current versus voltage of the PN junction diode is known as static characteristic of PN junction diode. Again, the graph of or the curve of I versus V of the PN junction diode is known as the static characteristic of PN junction diode. Right? Now, the circuit for PN junction diode for forward bias connection or the forward bias characteristic is shown in the figure. Now, symbolically, what is the figure? Actually, there is the part of our practical. In practical, we had to also do the graph. That means we had to find out the forward bias characteristic and reverse bias characteristic. In forward bias characteristic, we had to find out what is the resistance of a PN junction diode. Right? Okay. That is known as the dynamic resistance. What is the dynamic resistance in forward bias characteristic of a PN junction diode? So there is the practical purpose. The circuit is shown is also the same circuit given in our journal for the practical. Okay. Now, in static characteristic of PN junction diode in forward bias or the forward bias characteristic, the circuit for PN junction diode for forward bias characteristic is shown in the figure. Here the PN junction diode, P-type semiconductor or the P side of the PN junction is connected with a battery. N side is connected with the negative terminal of a battery. Okay. How much voltage is applied can be measured with help of a voltmeter. Voltmeter is always connected in parallel. Therefore, the voltmeter is connected parallel to the PN junction diode. And how much current flowing in the circuit? To measure this current, we are applying the milliampere. Milliampere meter is always connected in series. Therefore, that is connected in series with battery and PN junction diode. Voltmeter is in parallel with battery and also parallel to the PN junction diode. Clear this? Okay. So that is the circuit of a PN junction diode for forward bias characteristic as shown in the figure. Now, in such circuit, a battery is connected with a PN junction diode through a potentiometer or the rheostat to change the applied voltage. Now, in practical circuit here, the rheostat is connected in this manner, or the potentiometer circuit is connected. So this terminal is the variable. So as we change the position of this variable terminal, so resistance of the circuit is changed. As a result, the applied voltage change and whatever the current flowing in the circuit is also changed. Right? So in such circuit, the battery is connected with the PN junction diode through either the potentiometer circuit or the rheostat. In our practical, we are using the rheostat. Rheostat is the variable resistance. We can change the position of the pointer, therefore the resistance of the circuit is changed. Therefore the current flowing in the circuit and applied voltage in the circuit also changes. Clear this? Okay. Now, if the applied voltage increases, the current in the junction increases as shown in the figure. In forward bias, already we discussed, as the voltage applied is increases, so what's happened? More and more electron diffused from N to P are increases due to the positive potential applied at P side of a PN junction. And what are the holes are crossing the junction from P to N is also attacked by the negative terminal connected with inside of PN junction. Therefore, as the voltage increases, so more current or the current is also increased in the junction. That is shown in the figure. This figure, this quadrant represents the forward bias characteristic. Third quadrant represents the reverse bias characteristic. At present, we are discussing this forward bias characteristic. As the voltage increases, so current is also increased in the circuit. Right? Now, from this graph, initially the increase in current is less compared to the increase in voltage. In this region up to this voltage, the current is approximately 0. As we apply or increase the more voltage, so increase in the current is less. Right? As the voltage increases beyond a point, the rapid increase takes place in the current. The point at which the voltage shown, from this voltage the rapid increase takes place in the current. This voltage is known as the cut-in voltage or the threshold voltage. That is the cut-in voltage or the threshold voltage. Up to this voltage, the increase in current is less compared to the increase in voltage. Beyond this point, as the slightly voltage increase, so more increase takes place in the current. This voltage is known as cut-in voltage or threshold voltage. Again, now the circuit for PN junction diode for forward bias characteristic is shown in the figure. Right? In such circuit, a battery is connected with a PN junction diode through a potentiometer or the rheostat to change the applied voltage. Right? If the applied voltage increases, the current in the circuit or the junction increases as shown in the figure. As the voltage increases, current is also increase in the junction. From figure B, the initial increase in current is less compared to the increase in voltage. As the value of the voltage increases beyond a point, the current starts increasing rapidly. This voltage is known as the threshold voltage or the cut-in voltage. So only we have to describe this thing. Right? Now, the approximate value of the threshold voltage for germanium and silicon is 0.2 volt and 0.7 volt respectively. In some book that is given as the 0.3 volt, but in our NCERT book that is given the 0.2 volt. Right? The approximate value of the threshold voltage for germanium and silicon PN junction diode is 0.2 volt and 0.7 volt respectively. The current and voltage do not have the linear relation. Now here, the relation between the current and voltage is non-linear. That is the curved shape. Right? Hence, the Ohm's law cannot be used to measure the resistance of the PN junction diode. So Ohm's law we can't apply to find out the resistance of a PN junction diode. Okay. The dynamic resistance can be found at any point on the characteristic by taking the small change in voltage delta V and small change in current and their ratio. Therefore, the dynamic resistance in forward bias RF is equal to delta V upon delta I. The value of IF will be different at different point on the curve. Some students measure the dynamic resistance between these 2 points, while the one more student find out the dynamic resistance between these 2 points. So value of the dynamic resistance may be different. There is not occurs the same because the relation between the current and voltage is non-linear. That is the curve. Therefore, the value of the dynamic resistance of PN junction diode is not constant. The resistance of a diode in forward bias is approximately between 10 ohm to 100 ohm. The value of resistance in forward bias is approximately 10 ohm to 100 ohm. So there is the forward bias characteristic of PN junction diode, maybe asked for 2 marks, and also there is the part of our experiment. In experiment, we have to learn about the both type of the characteristic, forward bias and reverse bias characteristic of PN junction diode. Both are in our syllabus of experiment. Right? So that is very easy. If our concept about the theory is clear, so we can easily perform the experiment. Again, what is the static characteristic of PN junction diode? And explain the forward bias characteristic. Now, the curve I versus V of the PN junction diode is known as, or the relation between the current and voltage of PN junction diode is known as the static characteristic of PN junction diode. Clear this? Okay. The circuit for PN junction diode for forward bias characteristic is shown in the figure. That is the circuit diagram for forward bias characteristic of PN junction diode. Here, there is in forward bias, therefore P side of the PN junction is connected with the positive terminal of a battery, while N side of PN junction is connected with negative terminal of a battery. To measure the potential difference, applied potential difference, voltmeter is connected. Is always connected in parallel to the battery and also the diode. To measure the current flowing during the PN junction diode in forward bias, the milliampere meter is connected in the circuit. This milliammeter is connected always in series with battery and PN junction diode. So that is connected in series. Right? Okay. Now let's show the figure. Here the battery is connected with the PN junction diode through a rheostat or the potentiometer. What is the aim or what is the purpose to connect the rheostat or the potentiometer circuit with the battery? We make the change in applied voltage in forward bias connection. That is the aim of connection of the rheostat or the potentiometer circuit. Now, if the applied voltage increases, the current in the junction increases as shown in the figure. So this first quadrant represents the forward bias characteristic of PN junction diode. From this figure, we can say that as the current voltage increases, so current is also increases as shown in the figure. From figure B, that is figure B. The increase in current initially is less compared to the increase in voltage. Increase in voltage. From figure D, the initial increase in the current is less compared to the increase in the voltage. As the voltage or the value of the voltage increases beyond a point, the rapid increase takes place in the current. The voltage corresponding to this point is known as threshold voltage or the cut-in voltage. That means after the voltage increase beyond the cut-in voltage, the rapid increase takes place in the current. Right? The approximate value of the threshold voltage for germanium and silicon is 0.2 volt and 0.7 volt respectively. That means for germanium 0.2 volt, there is the threshold voltage, and silicon, there is the 0.7 volt. Right? Suppose there is for germanium, for silicon, the graph is like this. There is a rapid increase take place after the 0.7 volt. Okay. The current and voltage do not have the linear relation. Relation is not linear. That is the curve. That means the non-linear relation. Therefore, Ohm's law cannot be used to find the resistance of the PN junction diode. Already we discussed in limitation of Ohm's law. Right? Okay. Now, here the relation between the current and voltage is non-linear. Therefore, Ohm's law cannot be used to measure the resistance of PN junction diode. The dynamic resistance of a PN junction diode is measured at any point on the curve, on the characteristic curve, by taking the small change in voltage and small change in current and their ratio. Therefore, the dynamic resistance in forward bias RF is equal to delta V upon delta I. The value of this resistance is not same. Is different at different point of the characteristic curve. The resistance of a diode in forward bias is approximately between 10 ohm to 100 ohm. Clear this? Okay. So there is the forward bias of PN junction and forward bias characteristic of PN junction diode. Now we are going to discuss about the reverse bias and reverse bias characteristic of PN junction diode.